Hi, I would like to introduce today a circuit which basically is act like a trip alarm, a burglar alarm, and is made out of infrared LED, the transmitter and the receiver, the photodiode. So now there is an infrared transmitting between the transmitter and the photodiode. When this infrared light is interrupted, the buzzer will sound off. So now I should demonstrate how it works by putting an object in between. As you can see, this button is used to reset the buzzer, to off the buzzer, to reset the flip-flop in the 555 timer. I shall demonstrate one more time. Okay, now I shall describe the component of the circuit and the pin of the 555 timer. This infrared is connected to the VCC via a resistor, and this 555 timer, there are 8 pins. Pin 1 is connected to ground. Pin 8, which is directly opposite, is connected to the VCC. In this case, is a 9-volt battery. And pin 2 is connected to the photodiode together with the resistor at the junction. Pin 3 is connected to the buzzer at one end of the buzzer, and the other end of the buzzer is connected to ground. Pin 4 is not in use, so we put it in a high state by connecting to the VCC. By right, pin 4 is a reset pin. When pulled to low, it will stop all the operation within the 555 timer. So in this case, we do not want it to stop the operation totally. We just want to reset the flip-flop. So we are not using the pin 4. We are connected to a high VCC. And for pin 5 is also not in use, and to prevent floating, we attach a capacitor to keep the pin at a high state. And for pin 6 is a threshold pin. This threshold pin is connected to the tactile switch, and when it is pulled high to around 2/3 VCC, it will switch the output pin, pin 3, from high to low. That's how it stopped the buzzer. So currently, this tactile switch is connected to VCC. So when you press the tactile switch, which the other end of the tactile switch is connected to pin 6, and pin 6 will be pulled high, will be exceed 2/3 of VCC. So therefore, it will cause the output, which is pin 3, to switch from high to low, from on to off. So that's how the reset works. Pin 7 is not in use, and we leave it as it is, not connected. So basically, how this photodiode works is very simple. When there's light, the resistance drop. I mean, when there's transmission, the resistance drop. So resistance drop means less voltage drop across the photodiode, which cause the circuit to have a slight reverse current. And also, of the less voltage drop, the junction after the photodiode, which is connected to pin 2, the trigger, is held high. So when it's held high, the pin 2 is not being triggered. So that's how because of the transmission, there's no buzzer, because the pin 2 is not triggered. It's held high because of the less voltage drop. But once there's an interruption, when there's no light, no infrared transmission, the resistance increase and the voltage drop increase, which means at the junction after the photodiode, there will be voltage that is less. There will be a very low voltage. In this case, it will be lower than 1/3 of VCC, 3 volt. So therefore, pin 2 is an active low pin. It becomes low and is triggered. So this is basically how the trip alarm works. It's a very simple circuit, but there's a lot of basic electronic concept to be learned as a hobbyist. So I hope everybody will benefit from this video, from this blog. Thank you very much.